Today we're on pages 92 and 93 of our textbook, Unit 3, Lesson 7, Finding Equations of Exponential Functions. And it'd be very helpful, you want to have a calculator with you for today's lesson. So an exponential function has a constant multiplier. We'll learn how to write exponential functions. And that constant multiplier is known as the base. The base of your exponential function, y equals ab to the x. The base is the constant multiplier. Exercise number 1, an exponential function of the form f of x equals a times b to the x is presented in the table below. Determine the values of a and b and explain the reasoning. Okay, well, if we look at this table, as x is increased by 1, what's happening to the outputs? What's happening to the y's? What do you do to 5 to get 15? What do you do to 15 to get 45? You multiply by 3. So the constant multiplier here is 3. So 3 is our base. What's the a value? Well, let's say that if we evaluate f of 0 would equal a times b to the 0. When we input 0, the output is 5. So replace f of 0 with 5. 5 equals a times 1. So a is 5. Right? B to the 0 is 1. Anything to the 0 power is 1. A is 5. Our final equation, f of x equals 5 times 3 to the x. Explanation, a is the value when x equals 0. And b is the multiplier per unit increase in x. And we can certainly use our calculator to check this. We'll take our equation and put it into y1, 5 times 3 raised to the x, and look at the table of values. So an input of 0 has an output of 5, an input of 1 has the output 15, 2, 45, and so on. So we know that this is the correct equation. Now we're going to find an exponential equation given 2 points. Just like with lines, any 2 points will determine the equation of an exponential function. Here are the steps which you need to memorize. First, we write 2 equations, then we divide the 2 equations, we solve for b, and then solve for a. An exponential function of the form y equals a times b to the x passes through the points 2, 36, and 5, 121.5. So this is an x, corresponding y, an x value, and corresponding y. By substituting these 2 points into the general form of the equation, we create a system of equations with constants a and b. Okay. Now, I'm always going to start with the point that has a larger x value. Okay, so we're taking y equals a times b to the x, and taking the point 5, 121.5, putting 5 in for x and replacing y with the 121.5. So 121.5 equals a times b to the 5th. And our other point, the y value is 36. 36 equals a b to the 2nd. Next, we're going to divide the two equations. So the first step, write two equations. That's what we did here. Next, we're going to divide the two equations. So if I'm just use a division fraction bar here, 121.5, go to the calculator, divided by 36 is 3.375. A divided by A is, they divide out, and b to the fifth divided by b to the second is b to the third. Right? Recall that when dividing two like bases, we subtract their exponents. 3 says to solve the resulting equation from 2, which is here, for the base b. And how do we do that? We do that by taking the x root of each side. All right, so in this case, we have 3.375 equals b to the third, and we will take the third root of 3.375. Right? That's what we're doing. So we're taking the third root of both sides. So the cube root of b to the third is simply b. Now using the calculator, math, as it says in step 3, math 5 on the calculator. Let's get that back. So I just press the math, and now arrow down to number 5, and this is the third root, so 3 goes here for the root, and 3.375 is up there, so I will just arrow up, grab it, it's highlighted in blue, and press enter again. So b equals 1.5. So we have our b value. Now use our b value to determine the value of a by going back to one of the original two equations in step 1 here. So I'll go back to the 36 equals ab squared and replace b with 1.5. We want to get a by itself. Right now we have a times 1.5 squared. I'm not going to bother squaring that. We've got a calculator, so let's just divide by 1.5 squared, both sides of our equation. So on the calculator, 36 divided by 1.5 squared. I'll put it in as a fraction, just as it looks here. 36 divided by 1.5 squared is 16. So a equals 16. State the final equation. Our final equation is, this is in terms of y equals, so y equals, a is 16, b is 1.5, times 1.5 to the x. Again, you have to memorize these 4 steps here. Memorize that. You write 2 equations, divide 2 equations, solve for b, and then solve for a. Exercise number 3, for an exponential function of the form f of x equals ab to the x. It is known that f of 0 equals 8. Write that as a point. That's 0, 8. And f of 3 equals 1,000. That's the point. 3, 1,000. Find the values of a and b and write the equation. Okay, so we start by writing 2 equations. In the general form, y equals ab to the x. I'm starting with the point that has the larger x value. So y value is 1,000. 1,000 equals ab to the third. And then our other point, 8 equals ab to the 0. There's our 2 equations. Now divide the two equations. This is dividing, we're not subtracting, we divide. 1,000 divided by 8 is 125. Just check that, 1,000 divided by 8, yes, is 125. A divided by A, they divide out. B to the third divided by B to the 0 is B to the third. And now we're taking the third root of both sides. And in the calculator, that's going to be math number 5. So math 5, third root 3, and 125. Just go up and grab that, bring it down. It's 5. So B equals 5. What is A? Go back to one of the two originals. I'll go back to 8 equals AB to the 0. Substituting 5 for B. That's pretty easy. That's just 5 to the 0 is 1, so A equals 8. Don't forget, write the equation. So f of x equals, that's the form that was in the direction. So f of x equals 8 times 5 to the x. This is our equation. Let me just check it before I circle the answer. Go to y equals, this is 8 times 5 to the x. Check the table of values. And 0, 8, yep, that's there. And an input of 3, an output of 1,000, yes. So we know our answer, this equation is correct. Next, exercise number 4, an exponential function exists such that f of 4 equals 3 and f of 6 equals 48. This is the point 43 and the point 648. Which of the following must be the value of its base? So we want to find the base. So we'll stop at step 3 for this. We start by writing two equations. Y equals AB to the x. I'm starting with the point that has the larger x value. So 6 goes in for x and 48 in for y. 48 equals AB to the 6th. And our second equation, 3 equals AB to the 4th. Now we divide. Next step is to divide those two equations. 48 divided by 3 is 16, right? 48 divided by 3, yeah, 16. 16 equals, the a's divide out, b to the 6th divided by b to the 4th is b to the 2nd. And this is square root, so now we just square root each side. And we have b equals 4, which is option 4. Now let's practice with a decreasing exponential function. Find the equation of the exponential function shown graph below. Be careful in terms of your exponent manipulation. State your answer, your final answer in the form y equals ab to the x. All right, so here we have our 2 points. This point 2, 1/2 has a larger x value, so I'll start with that. Y equals ab to the x. 2 in for x, 1/2 for y. So 1/2 equals ab squared. And our other equation, 128. Right? This is our x, that's our y, x, y. 128 equals ab to the -2. Next, we divide these two equations. Right? This is a division line. 1/2 divided by 128. 1/2 is the same as 0.5 divided by 128. Well, we get this decimal, all right? I'm going to hit math, and then number 1 is for fraction. And I'm going to give the fraction answer of 1/256 equals, the a's divide out, right? These divide right out. B to the second divided by b to the -2, we're subtracting. 2 minus -2 is +4. And now we take the 4th root of each side. B equals, okay, so calculator, math, number 5, 4th root, and I have the fraction up there. I'll just arrow up and grab that, or you could arrow up to the decimal and grab the decimal. Either one will work. And enter, 1/4. So B equals 1/4. Does that make sense? Oh, yes, right? Because this is a base. And this base, 1/4, is less than 1. And we have a decreasing function. Remember, our base would be less than 1 if our exponential function is decreasing. We still have to find A. Go back to one of the two equations here. I'll go back to the first one. And I have 1/2 equals A times B is 1/4 squared. Again, we want to find A. We have A times 1/4 squared. Just undo the multiplication by dividing by 1/4 squared. So A equals, calculator, alpha y equals again, 1/2, and then we have 1/4 squared. So 1/2 divided by 1/4 squared is 8. Now we have our A and our B value. Our equation, y equals 8 times 1/4 to the x. Check it. Go to y equals 8 times, I'll just change that 5 to a 1/4 is the same as 0.25, but let me put it in fraction form. Put y equals 1/4. And delete that, and look at the graph. Or I'm looking at the table of values rather. Yep, -2, 128, and 2, 1/2, and zoom 6. Let me just look at the graph as well. Not that I had to here. Yeah, of course the scale is different. All right, that's -2, 128. My y values are only going up to 10 here, right? I would have to change the window, the y values to go to, let's say 130, graph that. But again, the graph is not necessary, right? The graph is not necessary. We already checked it with the table of values. Okay, so I'll circle that answer. This is correct. Now in exercise number 6, we have a bacterial colony is growing at an exponential rate. It is known that after 4 hours, its population is 98 bacteria. Okay, so this is time is input, and the output's the population, 98. After 9 hours, it is 189 bacteria. 9 hours, 189, definitely increasing. Yeah, as it did say, it's growing. Determine an equation in y equals ab to the x form that models the population. Y is a function of the number of hours, x, round to the nearest hundredth. Okay, so again, our 4 steps. We are going to write two equations, divide two equations, find B, and then find A. You have to memorize these 4 steps. Okay, so again, I will start with the point that has the larger x, the larger input value. Y equals AB to the x. 189 equals AB to the 9th. And 98 equals AB to the 4th. Now divide the two equations. Division line, 189 divided by 98. Ooh, not very nice. I'm going to math frac that. 27/14 is what I'm going to leave. 189 divided by 98. A's divide out. 9 subtract 4 is 5. So now I'll take the 5th root. And B will equal, okay, so math, number 5. And this is the 5th root of, and I'll just go up and grab that. Or I could go up and grab the original 189 divided by 98. We're to round to the nearest hundredths. So B equals 1.14037 something. 4 is in the hundreds place, so 1.14 is our B value. Now to find A, we go back to one of our two equations here. I'll go back to the second one. So 98 equals A times 1.14 to the 4th. We want A by itself. Don't bother keying in 1.14 to the 4th. Let's just get rid of the multiplication by dividing by 1.14 to the 4th. And A equals. $58.023 something to nearest hundred, that's 58.02. Our equation is y equals 58.02 times 1.14 to the x. This is our equation. And the last piece of this says the exponential growth can be modeled by y equals a times 1 plus r to the x. You had this formula back in Algebra 1, where r is the decimal form of the percent growth rate. At what percent rate is the population growing per hour? So in other words, we want to take this, just the base piece of this, right, and rewrite it as 1 plus r. Well, 1 plus r has to equal 1.14. So what is r? 1 plus what gives us 1.14? Well, just subtract 1 from each side here. And we have that r is equal to 0.14. R is the decimal form of the percent growth. At what percent? We want a percent rate though. Okay, so r equals 0.14. 0.14 as a percent is 14%. So we answered both pieces, the equation and then the percent rate of growth, 14%. Thank you very much for your attention.